Alright, so today we'll be talking about angles in a unit circle, and then we'll start talking about cosine of theta and sine of theta, which are some of the curves you'll be looking at as we go. Okay, so what we're going to be talking about is standard position and just working with it in an actual setting. Okay, so let's say we want to have an actual graph. Well, first off, we need an initial side. Okay, so the initial side is actually going to be this line right here. Okay, it's going to be this ray right here. Now, when we want to draw the rest of the angle, because if you remember, you have to have two of these angles as we work. Okay, this is going to be the terminal side. Okay, and this is called standard position, where we're actually centered at the origin. Okay, so that's standard position right there. Alright, so when you're ever talking about an angle, now here's the thing, we're going to use a letter, and some of you guys might use a different letter, but usually it's going to be called theta. Okay, so that's the angle. Now, counterclockwise is positive, clockwise is negative. Okay, so this is going to be actually one of the few times that you're actually going to get a negative angle. A negative angle just means you're going the other direction. So counterclockwise, you're going to go this direction. Clockwise, you're going to go this direction. Okay, now when you're drawing angles in standard position, and I'm going to go ahead and draw this out a little bit fast. We won't talk about that circle in the upper right hand corner just yet. Okay, so once again, standard position is going to stay there, so standard position will be right there. So if I were to draw a 45-degree angle, I would go from here to here, and my measurement would be from here to here. Okay, now if I were to draw a, let's say, 210-degree angle, okay, I would be going from this standard position or this initial position to this terminal position, and that would be 210 degrees. So 210 degrees, and this one right here would be 45. Alright, now if I wanted negative 150, let me see what that actually does it in the same spot. Okay, here's a unique thing about negative 150. It actually ends in the same spot as 210 positive. So we would call these coterminal angles. Okay, because if you were to draw at 150 degrees negative with the, well, you would actually turn your protractor upside down and draw 150 degrees this way. But with 210, you would go 180 degrees plus 30, which is the same as 180 minus 30 from here. So negative 150, 210, 570. These are all coterminal angles as we work with it. Okay, so these are all coterminal. They all end in the same spot. And if you ever want to find a coterminal with any angle, take that angle and add or subtract 360 degrees times k, however many times you want to go around, because there's actually an infinite amount of coterminal angles with any angle you pick. Alright, so now that we've talked about coterminal angles and everything, just working with it right here, now we're going to actually talk about points on the unit circle. Okay, so now here's the cool thing. As long as you know the angle you've drawn for the actual angle you're working with, you can actually find the actual point. Okay, and so this point is actually going to be, and here's the cool part, it's going to be the cosine of theta, the sine of theta. Okay. Alright, now, how do we actually get that, you say? What we're going to do is we're going to drop a altitude from the point to the actual standard, or the initial side of the angle. Okay, now let's say that this angle is a nice neat one first, so this is 60 degrees. Okay, so 248, there we go. Alright, so as we take a look at this, now cosine is going to be the x. Well, guess what? This is a 60, 30, 90 triangle, and in that type of triangle, okay, if this is a 1, so we know that this is an actual 1, we can actually find out the other sides of this. Okay, so if that's that, this is going to be 0.5, and this is going to be 0.5 square root of 3. Okay, because it's a special right triangle. All right, now cosine is going to be adjacent divided by this. Okay, so it's actually going to be 1/2 divided by 1, so this will actually be a half, so you can actually find out the exact values really fast. Okay, and sine is going to be, let me see, opposite over hypotenuse, so that will be that one right there. Or sometimes as we write as the square root of 3, okay, we'll have that in parentheses, divided by 2, which is the same as 1/2 times this. Okay, and the actual cool stuff is that you can actually use these angles, and especially in trigonometry, you can use these triangles and everything that you can draw in here to actually find that. Now, here's the really awesome thing is this is all first coordinate. What if we had an angle over here? Let's say that this angle was actually 210, just like what we were using earlier. Okay, so this is 210 degrees. Okay, so that's that entire angle right there. Okay, we can use a coterminal angle, which is 30 degrees. Okay, which it makes with the x-axis right there. Okay, now when I draw out, let me finish drawing the rest of this right here. Okay, all right, if that's 30 degrees, that would make this the 60 degrees right there. Okay, all right, now that would make this the, once again, this is a unit circle, so the radius is 1. Okay, that would make this side the 0.5. Okay, all right, and that would make this the 0.5 root 3 up here. Okay, now obviously you don't need to do the same path I did to get here. Now here's the thing though, is that if you notice I'm going to the left and down, so that these need to be actually negative 0.5 root 3 and negative 0.5. Whereas over here I went to the right, which is positive in the coordinate plane, and up. Okay? And if I wanted to find the points of that, that would be 0.5, or actually negative, no, actually no, 1, 2, that would be negative 0.5, that would be negative the square root of 3 divided by 2, comma, negative 0.5. Or you could say 1/2 if you'd like. Usually they like to use 1/2 here. Okay? All right? And you could actually find those points. Why? Because once again, cosine of theta is going to be the x-coordinate, and sine of theta is going to be the y-coordinate. Now, you are going to need to use special right triangles to actually work with this. So just remember that inside of a special right triangle, okay, as long as you remember that if this is 30 and this is 60 and this is 90, okay, that it's a 1 to root 3 to 2 ratio, and that also you're going to be using coterminal angles. Let's say that we were using a 45, 45, 90 triangle. Okay, this would be a 1 to 1 to root 2 ratio. Okay. Now, does this help actually find these actual measurements on a circle? Yes. Do we need it all the time? Not exactly, but you will see in the next couple of units us actually working out this stuff to actually find these exact values by graphing this over time. Okay. All right, that's it for angles in a unit circle. I will talk to you later. Bye.